Find the decimal form of 15/8. Mr. Kelly, are we running?
Yeah.
Good. Anybody know how to do this?
Don't you divide 15 by 8?
You do divide 15 by 8. And you know what? We can do that by hand, or we can just type that into our calculator,
Won't
right?
it be about 1.5?
No. But we can figure out what it would be if we just divide 15 by 8. By the way, calculators are a requirement for this class, so I know they're expensive. You can rent them from the library, or they check them out, but you got to be careful about that. They don't have enough for everyone, and you have to renew them every day. Okay, negative 11/6. Okay, we okay with 1.875? It's called a terminating decimal. That's the decimal equivalent of 15/8. Easy, easy, easy. Negative 11/6. Uh-oh. What does that notation mean? That's what happened when I typed it on my calculator. That means that decimal is repeating. So we have an example of a terminating decimal and a repeating decimal. Terminating and repeating decimals, these kinds of numbers are called rational numbers. So what's the definition of a rational number? It is a terminating or repeating decimal. And we have examples of both of those. Terminating, it ends. Repeating, it doesn't. Everybody okay? Now, next section, describe and graph. Who can read this to me? What does that mean? X is greater than 3. Perfect. Graph. We graph these, we put them on the number line. Anybody know how to graph that on the number line? Maya?
You have to have an open circle, or open, yeah. And it's the arrow's pointing towards the positive numbers.
Like this way?
Yeah.
Yeah, that's exactly how we would graph that. That is exactly the way we would graph that. Now, we are big kids now, so we need to be able to write this or recognize this in another kind of notation. This set of numbers, which is all the numbers bigger than 3, somebody said it, all the numbers greater than 3, can also be written in what is called interval notation. Now, sometimes they do this in second year algebra. Did any of you guys do interval notation last year? So you kind of know what it is. If we want to talk about all the numbers bigger than 3, we can write it this way. That's called set notation. Or we can write it with an interval. And as an interval, it would look like this. Now, we all know what 3 is. What's that?
Infinity.
That's the infinity symbol. What do you think this means? Does that kind of make sense to you? It says we're going to start at 3 and go to infinity. Isn't that what that picture is?
Yeah.
Now, it is very, very important that you pay attention to this right here. The parentheses notation means an open interval. And obviously I need an open interval because the dot is open. And it's open because there is no or equal to. Right? Now, when I look at the next problem, and I'm going to graph this on my number line, notice there's an or equal to, which means this picture will have a closed dot, right? Okay, so what's this going to look like?
It'll be it'll be -4 with an open dot, and then it'll have 2 with a closed dot, and then you'll have the squiggly in between.
Shaded in between, that's right. You can use a squiggly if you want. It's somehow shade in between. That is exactly correct. Now, your job is to communicate with me if I did something you don't understand. Otherwise, I'm just going to keep on rolling.
Wait, why is it in between?
Because this literally says that x is bigger than -4 and it's less than 2. So if you have to be bigger than -4, that means you're that way. But if you have to be less than 2, it means you're that way. So which numbers are both? The ones in the middle. Now, what would that look like in an interval? Well, there's no infinity this time, is there? Because we're stuck between these two numbers. This one will have a parentheses. Why? We already talked about it. It's open. Anybody know what the closed one is?
Bracket.
It's a bracket. That tells me it's closed. So this would be the interval notation for this set and this picture. These are all the same thing. They're just written different ways. Well, the next one, they actually gave to me as an interval. Now, I know that looks like an ordered pair. That looks like a point that you're going to plot, left 1, up 3. You have to just be careful and pay attention to the context. This is an interval. So what would that look like on the number line?
Wouldn't you have open dot at -1, open dot at 3?
Open dot at -1, yes, thank you.
And then you would have the squiggly in between them.
And an open dot at 3 and shaded in between. What would that look like in a set? What if I wanted to write it this way? What would it look like if I wanted to write it that way? Maya?
-1 is less than x, but greater than or equal to the square root. Or is it just greater?
It's just
Less than.
So -1 is less than x is less than 3. Let me give you a little hint. Any time that you're describing a situation like this, where you've got two numbers and you're coloring in between them, any time your symbols are going to be less thans. You're never going to use any symbol other than less than when you have this situation. See, less thans? Always, 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 you're going to use less thans when you have this situation. All right, there's two more. There's a D and an E. I need some volunteers to come to the board. In this class, we never have to come to the board by ourselves. We can always bring a partner if we want. We can fly solo, but we can also come with someone. So I need somebody to come up and do D, and you got to be on this board because this is the only board that videos. So we got to do this one. All right, you got D, and I need somebody to come up and do E. I want you to draw a picture of E. Here, marker. So she's going to do D. Who's going to do E for me? Oh, this is not good.
Olivia, you want to?
Yeah, sounds like a great idea. You
I'll
can go
help
on
you,
up.
Katie. Yeah, come on.
Okay, all right, let's go.
Let's do it together.
Now, what should the rest of you be doing?
This word.
On your paper, you should be making your best guess.
What's the problem?
You're doing E.
You gotta erase.
Yep, you can erase it.
Katie, can you?
And everybody should be drawing a number line, putting dots on it, and coloring it. Everyone should be doing that.
You gotta write the problem. Yeah, go ahead.
In this class, I know today maybe you weren't totally prepared, but everything we do in this class should be in pencil, right? So that if we don't do it right, we can erase it and start over.
Bracket is closed. Okay, so now I have to write it as a big open. And then it's
If it's closed, it's a parentheses, right?
If it's closed, it's a bracket.
Oh, okay.
Always less than.
So wait, it'll always be less than.
And you color that dot in. Yep, there you go. Okay, let me get some of this other stuff out of the way so we can see what they did. Now, you have all done this on your own. So let's see how you did. This was D. This is the picture the girls drew for D, and this is the set form of the answer. What do you think?
Yes.
Anybody want to argue with that?
No.
I think they did a great job. Anybody have an issue? All right, then our other group. Oh, did you know what that meant? We didn't talk about that, but that's a negative infinity, right? So that tells me I'm going this way on my number line, which is exactly what they did. Should they have put a closed dot here?
Yeah.
Absolutely. Now, let's take a look at this.
Equal to.
Yeah, we need an or equal to on this guy because that is a closed dot. Otherwise, absolutely perfect. All right, how are we? Are we still doing okay? Now, part 3 we've already done. We've already talked about it. Nothing new here. Do you recognize A? I'm looking at part 3 now. A is an interval. I want you to write it like this. We've already practiced it. You're good at this. So I need somebody to come up. When it says write as an inequality, it means write it like this or like this. These are inequalities. So do I have a volunteer to come up and do 3A on the board? Write it as an inequality. You can graph it if you want. Don't have to. Write it as an inequality. Who's going to do 3A for me? Thank you, Tyler. I love you. B. Great. And C.
Yeah, boy, Tyler. That boy.
Come on. Thank you. So we've got A, B, C. Remember, you can take a friend if you're unsure. We're going to put A, B, and C on the board, and you are all doing A, B, and C on your paper. You're writing it like an inequality.
On this one, do you never put negative in?
No, not an inequality. No, but you need an equal to on that.
So it's always less than.
When you write, when your X is between two numbers, it's always less, this number's always less than. You done already?
Yeah, it's less.
All right, here we go, gang. That didn't take long at all. These people are good. Here's A. Take a look at the interval that's on the paper. Take a look at what he wrote. Did he get it right?
Yes.
He absolutely did. Beautifully done. Beautifully done. Let's look at B. This is what's on the paper. What do you think about that answer?
Should be a line underneath it.
We need a line underneath it. And why do we need a line underneath it?
It's closed.
Because it's a closed bracket. If I graph this on my number line, I'd have a closed dot at 6, right?
Yeah, and since do we put X, or can we put that fanny greater than 6?
We put X is greater than 6. That's the answer. That's it. Yeah. Remember, you're only going to have an answer like this if you're talking about X being between two numbers. If infinity is involved, you're either talking about going that way on the number line or going that
But I
way.
mean, like for our answer, can we write infinity greater than 6, or do we want to?
No, this is what you write as the answer. Yeah, that's it. That's perfect. And how about the last one? I didn't even give the interval, I gave a picture. Is this, would you say that's right?
Yeah.
And if you wanted an interval, it would look like that, wouldn't it? Oh, speaking of which, look at number 4. We've already done this. Number 4 says, okay, take these sets, or pictures, and write them as intervals. So if you have not been to the board yet this morning, I am going to encourage you to come up and do 4A, 4B, or 4C. So who will that be? 4A, 4B, and 4C. There we go. Everybody else should be.
Is that a line
Is it
underneath?
supposed to be a line on 4A?
Yeah.
Is that a?
I think there is one under there. That didn't come out very well, did it?
Wait, that's a line?
Well, let's put one under there. We can't really tell if there is one or not. We'll put one under there and see. We'll pretend it's there.
She has degrees.
Okay, groupies. Oh, whoa. Here we go. Here we go. Here's A. Now, we went ahead and put a line underneath that inequality there. Can't tell if it's supposed to be there or not. If it is, this would be the answer. That's exactly correct. Everybody okay with that? B is right here. What do you think about B?
Bracket negative 3, 4, yeah, that's right.
And C.
Yeah, that's
Yep.
I didn't talk about it, but whoever did this recognized it. Infinity is always open. The infinity interval is always open. So maybe that makes sense to you. You can't ever get to infinity, so you can't ever like color it in. So whenever you're using an infinity in your interval notation, it's going to be open. Good job. All right, now we've got something different. What is the additive inverse? The additive inverse. Does anybody have a clue what I'm talking about when I say additive inverse? What? Somebody said it, I thought. Opposite? It's the opposite. It's the opposite. So let's do B first. What's the additive inverse of 16? Negative 16. The additive inverse is whatever you would add to your number and get 0. So since I'm looking at B, since I have a 16, I'm going to add a negative 16, and that would give me 0, right? So the additive inverse is negative 16. Now, because I'm mean, I got wild and wacky with the A, number A. What's the additive inverse for negative 3 plus pi? It would be positive 3 minus pi. So the additive inverse of this number
Oh, so it's just the opposite.
is the opposite. It's the opposite. The additive inverse is the opposite. Now, I only put 2 examples on there because I think that's a pretty simple concept. When Mrs. Ford or somebody else says additive inverse, what pops into your head? Opposite. So if I said what's the additive inverse of P, you would say negative P. If I said what's the additive inverse of negative 2/3, you would say positive 2/3. Okay, you guys are geniuses. All right, number 6, here we go. Use the distributive property. Now you've been distributing since you were like in 3rd grade, so you know how to do this. When we say distribute, we mean take this guy times both of these, right?
Yep.
So here we go. Fox, are you watching the clock?
Oh, no.
I hope not.
I was not.
Wait, what
I was
time
just
do we
looking
get out of
around
You
here?
know what
classroom.
Mrs. Ford's motto is?
What?
Time will pass, will you?
Yes.
She's a savage.
Here we go. Hey, Precal's not about self-esteem. That's not what happens in this room.
You are a savage.
Here we go. Here we go.
Wait, what time do we
3x times 4x. 3x times 4x. 12x squared. 12x squared. Remember, when you multiply 3x times 4x, you're going to multiply 3 times 4, and you're going to multiply x times x. X times x is x squared. Then we're going to say plus 6xy, and there's our answer. That's called the distributive property. Very good. Now, what you may not be as familiar with is the distributive property works both ways. So in other words, you can start with the parentheses, get rid of the parentheses, which is what we did in our first example, or you can put the parentheses in, kind of undistribute, or what we call factor. That's the distributive property also. So when I look at this, what could I take out of that?
X.
And x. And when I do, I would have what left?
5x
You are exactly right. These are both examples of the distributive property. The distributive property works both ways. All right, what about B? Same thing. Kind of undistributing this one. What can we do with B?
A squared Z.
What can I take out? An a squared and a z?
Yes.
And if I do that, please be careful, you can do this. What happens if I take out an a squared and a z? What do I have left here?
A plus Z cubed.
How many z's?
3. 3. 4. 4.
I think it'd be 4, wouldn't it? Aren't there 5 of them sitting there, but I only pulled 1 out?
Yeah.
Okay, next. How about this one? What's that going to do for me?
10.
Perfect. All right, let's skip, we don't need to do E and F, you guys got that down. Let's look at number 7, we got to talk about these exponents. Problem number 7. All right, here we go. Any ideas? Cancel, very good. Now, when we cancel, I mean, we're smart about this. I look at my fraction. Where do I have more x's, on the top or the bottom? On the top. How many more x's are on the top than are on the bottom? 1. So there's just going to be a little x all by himself up there on the top, right? Let me say this one more time. There are more x's on the top than there are on the bottom. So whatever my leftover x's are, they're going to go on the top because that's where there's more. Since there's 3 of them up here and 2 of them down here, there's exactly 1 extra x on the top. Now look at the y's. Same thing, only the extra this time is on the bottom. That's it. That's all there is to it. Let's skip to C. We'll come back and do B in a minute, but let's do C. Because it throws in a little bit of an added complication. We are, after all, 4th year math students, so we can't do just easy problems. What do you think we're going to have to do first? Don't you dare start canceling until you do something first. What do you think, RoCap? Okay, I am on problem C. I skipped to C. I know you were, yeah. I skipped to C real quick. You need to take care of this, don't you? Now, that means you're going to square everything in this parentheses.
Yes.
You're going to square everything. So what are we going to have here? 16x to the 4th, y to the 5th, over 4x squared. Now, see the 16 and the 4? We can take care of that, can't we? What's going to happen there? We're going to have a 4 on the top. That's going to cancel. We're going to have a 4 on the top. Now, let's look at our x's here. Who has more? How many more?
2.
So we're going to have an x squared on the top. What do I do with that? Let's put it there. There's our answer, right? Let's do E, and then we'll do the other column, because this E is another one that's kind of the same thing. Anybody have an idea what to do with this guy? We're going to cube everything. You got to cube the top and cube the bottom. Now I want you to be real careful with this. When I say we're going to cube x squared, what does cubing mean? When I say we're going to cube something, what does that mean? Times it by itself, not times it by 3, but times it by itself 3 times. So this would be, if I wrote it out, which you don't have to do, but if you get confused, write it out. This would be x squared times x squared times x squared. Right? How many x's is that, guys?
What?
2 there, and 2 there, and 2 there. How many is that?
6.
So this would be x to the 6th, because it's x squared 3 times, There's 2 x's, 2 x's, 2 x's, that's a total of 6. Over what? 27. If you said 9, you're a goofball. This means 3 to the third. And what does 3 to the third mean? 3 times 3 times 3. Right? That's how we got 27. You have to be careful. I know you all can do this, but you have to be careful. All right, now, row cap, we're going to look at these negative exponents and review what that means. You people already learned all this stuff. We're going to review what this means. Now, what did you say, Mr. Rocap? Because you were right.
Which one are we doing?
Now we're back on B,
Okay.
which is the one you tried to do before.
Yeah, because I didn't see that problem there. We flip them.
What?
You flip them.
You flip them. A negative exponent on a fraction turns the fraction upside down. So my first step will be to turn that fraction upside down, and then I will raise it to the second power. So let me say that again in case you forgot what Mr. Miller or Mr. Thompson taught you last year. When a fraction is raised to a negative power, it turns the fraction upside down. So the fraction flips and the power becomes a plain 2 instead of a negative 2. Then we do what we did. This means square everything. So what's this answer going to be? Square everything. X squared, y squared, over 9. Very good. Now, that situation is a little bit different than what's happening here. Because here, the whole fraction isn't raised to the exponent. Do you see the difference? There, the whole fraction was taken to the power. Here, just pieces of it are. So we have to treat this a little bit differently. Anybody remember how?
You
Yeah.
flip the x, like you put x to the fourth on top and x to the second.
Anything that has a negative exponent gets moved. You're exactly right. So, this guy, I hope whoever's talking is talking about math. This guy is going to go to the bottom. This guy is going to go to the bottom. And notice when I move them, they become positive. Now, what about that z? He just stays there. What about that x to the fourth? He stays down there. How about this guy? Moves to the top. How about my z to the sixth? Stays on the bottom. So step 1, anything that has a negative exponent is going to get moved. Everything else stays the same, but if it has a negative exponent, it's going to get moved. That is a mess. What shall I do now?
Combine like terms.
Ooh, combine like terms. That sounds awesome. All right, let's start with our z's. I got a z to the first on top and a z to the sixth on the bottom. What's that going to leave me with? Z to the fifth, where? On the bottom. All right, I got this y to the fifth and y cubed. What am I going to do with that? 2 on top. Wait a minute now. These guys are both on the bottom. I put them together, and if I've got 2 of them here and 4 of them here, that's going to give me a grand total of 6 of them. There you go. Very good. Tough problem. Lots of steps. You're amazing. All right, last one. Step 1, you better know it. Flip it. That guy's going to flip, and he's going to become x over 2 to the second. So the answer is x squared over 4. You guys are my hero. All right, Kate, scientific notation. Oh, this is easy. Oh, now don't complain. It's easy. Scientific notation, what do you think? Anybody remember how to do this? Oh, did you people take chemistry? Come on.
You just write it.
3.14683 times 10 to the something. How did you get 5? 1, 2, 3, 4, 5. Remember doing that in chemistry like 7,000 times?
Yeah.
3.14683 times 10 to the 5th. .7136. What will that be in scientific notation? 7.136
Times 10 to the negative.
times 10 to the negative 1. Kids always say, Mrs. Ford, I can't remember. Should the exponent be positive or negative? Because in this case it was a positive 5. In this case it was a negative 1. Okay, you can memorize the rules about moving left or right, or you can just remember that big numbers have positive exponents and little numbers have negative exponents. So if it's a little number, it's going to be times 10 to a negative. If it's a big number, it's going to be times 10 to a positive. Right? All right, we're almost done. I think some of you are getting bored. I don't understand it. 9A. What a mess this is. We got to simplify it. Do you have a thought? I'm going to take out my handy dandy calculator. And the first thing I'm going to do is I'm going to multiply that number times that number, and I'm going to divide by that number. Scientific notation, numbers consist of 2 parts. The decimal part and then the times 10 part. You handle them separately. So I'm going to take care of the number parts. So 3.16 times 1.43 divided by 1.23 is 3.67. I'm going to round it off. 3.674. Did the bell ring?
Oh, it should be.
Wait, you times the top.
It's a multiplication and a division, all in the same problem. What time does the bell ring?
30. You said that part's fast. It's based off iPhone time. So give an
There it is. All right, you guys, have a great weekend. Remember, you have homework. Get your sheets signed and do the problems that I have posted on the website. They're online.
I'm gonna